Welcome back. This is part 3 of session 2. We are still talking about the real life examples. In the past, we talked about some of the real life experiences you had when you were in your mother's womb, perhaps facially recognizing your parents when you were a couple of weeks old, a couple of months old. Then you came up to have a shopping list, and then you wanted to choose a college to go to. That's actually Bayesian algorithm. And when you wanted to do a decision tree, that's kind of a Bayesian algorithm that helps you as well to go and choose the program and the college of your choice. That fits the best with your criteria, by the way. As I said, you are a naturally born data scientist. My examples are about to end. I just want to give you a few more examples and conclude with some statements that I would like you to carry with me in the follow-up sessions, please. Okay. When, of course, in the age 14, 15, 20, you watch movies. And perhaps you watch movies with your parents, your siblings, perhaps most of the time you watch movies with your friends. And the way you do, you don't go with a friend who doesn't share the same interests as you do and watch a movie that doesn't fit either of the spectrum of interest, yours or the other person's. What happens is that you come up to have an intersection about the movies that you want to do, and the type of category you would like: drama, romance, sci-fi, documentary, comedy, which is very often quite common, comedy. What happens is that many of the cable programs and, for example, Netflix. Of course, Netflix is not a cable program, but provides you with a platform where you are going to choose your movies and watch on a subscription basis. What happens is that they actually make money by recommending you movies that seem to fit with your taste of the movies you have watched. They take a look at your past behavior. And they say, okay, this person has been watching sci-fi. This person has been watching comedy. And if you take a look at underneath of the movie that you watch, of course, you are supposed to be logged in. Netflix is going to actually recommend to you another type of a comedy, a movie or a comedy series that is going to interest you and your partner that you are going to watch, right? As a matter of fact, this is a very important data science concept, data science project. So what I would like to, there was a 1 million prize for improved recommendations engine by Netflix, I believe some 7 years ago, 6-7 years ago. What happens is that they take a look at the different users, they take a look at the different movies that they have been watching, and then they come across and they say, okay, let's recommend a very specific movie, not just one, perhaps a train of movies, 7, 8, 9, 10 of the movies that seems to match with your criteria. Same thing is true for Amazon.com, Amazon.ca, or any other Amazon site. You go and you buy something, and they give you different types of recommendations. If you are buying a laptop, it could potentially tell you that you have different, you're looking at Asus, and maybe you could also look at the Dell, HP. There will be one possible recommendation simply by matching what you're looking for. Another possible recommendation is not necessarily exactly a laptop, but the accessories. So you're going to buy something, say, for example, Asus, and then they are going to say, okay, you better have a microphone, you better have a pad to basically write on. All of those accessories, they are going to be recommended to you, and they make money because of that. And you're also, you don't mind looking at those recommendations because they are going to help you to basically assemble the tools that you need to do the task. For example, if you're buying a camera, a high resolution camera, then you need a tripod. Then you need a case for that camera. So these are the things that they will be recommending. This is exactly what a data scientist has done, implemented, and then you see the conclusion. The conclusion is A high resolution camera is recommended with a tripod, a case, other lenses, as well as the same camera has been recommended from different companies. So you often end up having two lines of frames of recommendations underneath of the choice you make. It could be Amazon, it could be anything else, right? This is a nice example, not necessarily true, but it is a nice example to keep in mind in terms of the hierarchy of the terminologies you have seen. You have heard. Artificial intelligence, this is the skull. Machine learning is going to be the whole of the brain, and deep learning is going to be deeper inside. Again, it doesn't mean that the deep learning is actually here. It's not physically there, but it actually shows the hierarchy. I mentioned that you are a naturally born data scientist. So if you are a naturally born data scientist, what are you doing here? You are trying to either look at machines, computers, as assistive tools, or you are going to replace the task with a computer. Anything that is repetitive can potentially be replaced by a computer, anything, including driving. So now you see that the self-driving cars are actually coming onto the streets, right? There is no driver behind them. You want to go from A to B, majority of the airlines actually fly planes that much of the distance flies on an automatic pilot. Did you know that? So what is happening is that more and more, much of what we actually do, if it is repetitive, can be replaced by a computer. But at the same time, keep in mind, the complexity of the subject is so huge, you cannot easily replace a human with a computer completely. So what happens is that we are looking at augmented system where humans are going to be the ones that are going to conduct and order the computers to carry on the tasks through the codes that they write, okay? So this is a kind of a hierarchy. Keep in mind that this is you, and we are trying to remove many of the functionalities you do and replace it with a robot, okay? Let's take a look at you once again. This is a human body. You have the brain on top. You do have the audio that is coming in. We had some examples. You have sight coming in. You have a smells. We didn't have a smells as an example, but you can relate to. We have taste. Of course, you can relate to that. Chips are quite tasty, aren't they? Especially if they come with a hot, peppery kind of a chips, right? So the taste are basically a very important data entry point for the human body. Now, of course, you are going to generate some outputs. You are going to have a speech coming out of your mouth, and this speech is going to fed back into your auditory system. Potentially, you are going to see whether you are actually you're actually giving out the proper sequence of words and spelling and everything else. Pressure, touch, of course, skin is a huge part of the data entry. As a matter of fact, each one of these have their own huge complexities, eyes, ears. We are not in the place to talk about anatomy. It's not, I'm not an expert, but if you take a look at the human body, take a look at the amount of skin that the human body has. And then you're supposed to, as part of the ear system, you have something called for balance, body balance. You also are going to look at the center of gravity. You actually sense a lot, and your brain is going to basically process those incoming data. This is exactly what a data scientist is supposed to do, except that the brain is supposed to be at least partially or fully, based on the task, replaced by a machine. Here you have nerve talking to the brain, and the commands that are coming there are quite natural, coming from chemical reactions and physical reactions and all that, electrical reactions and everything. But in your case, you're actually going to write the code. That is why we said that you need to have the coding skill in this program. This is just a funny way of showing that what we are trying to achieve. Here is your wonderful brain, and here is what the machine is supposed to be. Perhaps you can coexist. Perhaps the brain, with all the peculiarities and complexities, is actually more functional and better at many tasks compared to the machine. And machine is a lot better at many tasks compared to the human being. And we know how to divide the tasks, but eventually they could potentially coexist and do a better job. Now, keep in mind, at some point, and this is beyond the subject of this class, we are looking at quantum physics, and where we are going to actually allow trillions of computations per second using quantum theory. So that's a different topic. And if that happens, of course, either they are going to adopt it inside the computer system, or obviously there is going to be a kind of a trade-off between human brain and quantum computing system. Far from us at this time yet, and lots of challenges to solve. Once again, I want to re-emphasize what the data scientist is supposed to do. This is you. You are going to have a lot of incoming data. Then you are going to do, for example, through the eyes, you're going to do image recognition. Through the speech and auditory system, you're going to actually process the languages. You are going to do a lot of planning, of course. You're going to predict. Remember, you wanted to buy a house. You're going to predict the resale value of the house. The resale value of the house is kind of future, not today, 4 years down the road, 3 years down the road. So that's going to be a predictive analytics. All of these are part of what the data scientist is supposed to do, except that you did it naturally. Now we are going to do it through computer. So what do we need? We really need to understand how the eye processes the images, how the ear processes the auditory signals, how the skin's information are collected and processed and classified. Right? So keep in mind, you could either, at some point, you could either basically do them individually, discreetly, or you could put them together and make an outcome, a single outcome basically presented unwantedly. For example, when you go to Facebook, when you go and have a cup of coffee with someone, allowing the rules and regulations, of course, during the COVID-19 time, what is happening is that at some point you're going to say, I'm going to have a cup of coffee with this person, and I'm not going to have a cup of coffee with this person. I like this person, I don't like this person. You don't have to go about it in an aggressive way. All you have to say is that I'm going to defriend him or defriend her or defriend whatever the other side of the story is, right? So at that time, you did a classification. When you go to Facebook and you say friend, not friend, you simply classify. When you say, I'm going to work with you in a project as a teammate, you are actually classifying. That's exactly what the data scientist is supposed to consider. One more time, I want to leave this segment of the recording with two important slides. One of them is the pipeline. No doubt, I want you to remember the pipeline. That is, at the very beginning, you are going to collect the data, and at the end, you are going to visualize so that the next step in life is going to happen. And another thing that I need you to keep in mind, do not be confused as we progress through the stages of the lecture series. We need to know a bit of math and statistics. We need to know coding, and we need to have the domain's knowledge so that a data scientist can function properly. Without the coding or the knowledge in the science and in the statistics and math or domain experts, you are actually not complete. With that, I want you to remember these two slides, please, as we go into the future lecture series. And by this, I'm going to end my session number 2. Thank you.